Hello, this is Jennifer Martinez. Today we're going to work on the notebook on section 2.4, Equation for Lines in a Plane. And I'm just going to read that first paragraph there. Remember, the graph of an equation with two variables is the set of ordered pairs, x, y pairs, that make the equation true. This concept is super useful for thinking about the relationship between an equation and its graph. And to see this, let's look at example 1. It says your friend Abel was asked to draw a graph of this equation, y equals 3 plus 1.5 in parentheses x minus 4. He shows you the following graph and asks you if he did it right. So we want to check. Did he do it right? What we're going to do is we're going to plug in 2 points from the graph to check his work. I'm looking at this graph here, and really the only 2 points that are right on the cross marks are maybe this one and this one. So those are the 2 points that I am going to check. This first point here is 2, 0. So what I'm going to do is I'm going to plug in x as 2 and see if y is really 0. So I'm going to plug in 2 into this equation. And when I figure that out, I'm going to do the parentheses first. I can use a calculator there. 1.5 times 2 is 3, so that would be a negative 3, and that is indeed 0. So the first point does work. By the way, this is called the x-intercept, which is what the key concept in this section is going to be about. It's the x-intercept. It's the x-intercept because it crosses the x-axis. And notice when you have an x-intercept, when it crosses the x-axis, we know that the y is 0. So that's something we're going to use in the future. Okay, what about this one? This is the point 0, negative 3. So I'm going to plug in a 0 here and see if I do indeed get negative 3. 0, 1.5 times negative 4. Again, you can use your calculator for that, but that's going to be negative 6, which is indeed negative 3. He did it right. It did work. This, by the way, is where it crosses the y-axis. So it's called the y-intercept. And the y-intercept, if you notice, is when the x is 0, the opposite of the y, opposite of the other one. So let's go ahead and do the same thing here. It says, I'll give you a moment to try this. Plug in points to match each graph with one of the equation and then find the slope of each line. So go ahead and take a moment and see if you can figure out which graphs represent what. Here's the x-axis. Since it looks kind of crazy, this one is the y-axis. There's the point 0, 0. Pause, take a few minutes, and then come back and look at the solution. Okay, let's go ahead and look at this. So I'm going to look at the first one, part A. So I'm going to go ahead and make a table, and I'm going to go ahead and plug in a 0 because I think that's quite easy. And I would get 4 there because this whole thing would be 0 there. So 0, 4 would be that point right there. So it can be 2 lines. There's a couple of them there. So I do need another point. That, by the way, again, is called the y-intercept. Notice the x is 0 when you get the y-intercept. But so I could plug in 3. That might be another one. Or I could plug in 6. But I'm going to go ahead and just find the x-intercept. To find the x-intercept I saw before, I know the y is 0. So this one is the x-intercept. That one's going to be a little bit tougher to do. I realize you could have done it a different way. You didn't have to do this. If you plugged in another value, that would be fine. You don't need to redo it. But just to show you this method, because we're going to be doing this in the future in this section, I'm going to subtract 4 from both sides. I'll multiply both sides by 3. And I'll get negative 12. The 3's cancel there, giving me negative 2x. I'll divide both sides by negative 2, and I'll get 6. 6, 0. So it had to be this line. This was the part A. Let's do part B in a different color. Okay, so plugging in my 0 for x, that would just be 0 for y. That looks like it has to be that one. By the way, this one, the x and the y-intercept, is both 0, 0. It's both the x and the y-intercept. Has to be, there's only one for that, so it has to be that one. But if you wanted to check another point, you could check like 3. And 3 would be 2. To see that, you would plug in a 2/3 times 3. 3's would cancel, or you get 6 over 3, which is indeed 2. Okay, what about C? Let's do that in a different color. There is no x here. What are we going to do about that? Well, when there's no x, that means y is always 4. Where's the only other place that y is 4 is this line. If you notice, no matter what x is, this is what this means. Y is a constant 4 because there is no x. So 0, 4, 1, 4, it has to be this line. That is the C. X is 4. Can you make a guess which one's X is for D? Yep, X can only be 4. I guess we should do it a different color. There it is. Oops, not there. Oh, X is 4. Oh, I made a mistake. That is X is 6, isn't it? That one is not here. Where's x4? X would be 4, would be right there, not on graph. The one that is right here is the F. F is the x equals 6. That's this one right here. That would be the F. E and D are both not on graph. Y equals 6 is where the y is 6, and that is not on graph as well. I missed that. Okay, so those are the answers to those. So in general, what did we learn? If you notice, when you have y equals some constant, either 4 or 6, that means that y is always going to be 4, or y is always going to be 6. So it's going to end up being a line like C that is horizontal. And the graph of x equals, on the other hand, we had like this one was the x equals 6, but even the x equals 4, that means x is always 6 or x is always 4. Those look like they're going to be vertical lines. So those are the two words that go there. The slope, we haven't talked about the slopes. So let's go back and look at the slopes for this. Part A, what is the slope? Well, we know the slope is the thing right in front. It looks like it's negative 2/3. Let's look at A. There it was. If we go down 2 and over 3, it does make sense. Yep. Part B, what was the slope for part B? Part B was positive 2/3. It's the thing right in front of the x. If we look at B, it goes up 2 over 3. Up 2 over 3. That makes sense. C. What is the slope for C? Well, it has no x. So the slope is going to be 0. The slope for C is going to be 0. And it does make sense because what is the slope again? It's the rise over the run, or the change in y over the change of x. And notice how we're not going up or down. We're not, so it's 0. On these two, we rose 0, we ran 1, but it doesn't matter. The whole thing is 0. The slope is 0 for any horizontal line. So they have down here, horizontal line, the slope is 0. A vertical line, on the other hand, let's look at F, for instance, was the vertical line. What's going to happen there when you look at your rise over the run? This time the run is going to be 0. If you just take 2 points, any 2 points, right, this would be maybe, let's just look at that. X is always 6, y could be anything. So you can see the rise between these two is 1, but the run is always 0. This is undefined. Which means, if you lower your page now, the vertical line, the slope is always undefined. And that is the answer to what the slopes are of horizontal and vertical lines. So we've learned about the intercepts, we learned about horizontal and vertical lines. Let's go to the next page.